In this video, we'll take a look at the practice test for Module 5. There are 10 questions, and again, we're looking for strategy to get to the answer. As we look at this first example here, we see we have a binomial squared, and that's equal to a negative 16. Now, in some cases, our answers may be imaginary answers, so we'll need to use the letter I. So the technique that we have gone over in our module is to take the square root of this side to get just the radicand, and plus or minus the square root of this side. So we've set it up, and the strategy when we want to get rid of an exponent like this, we use that radical operation. Here there would be a 2, but we don't write it. So when this is 2 and this is 2, then this just becomes the radicand. But if we take the square root of something, we say we take plus or minus the square root of that as well. But notice, under a square root sign, you cannot have a negative 16 as a real number answer. But if we take out the letter I, we go plus or minus I, the square root of 16. Then this is going to be plus or minus 4i, and on this side x plus 1, and you're just going to transpose this positive 1 to the other side, and those are your answers. Now remember, in Math Lab you usually have to separate plus this and then another one minus this once you transpose. In example 2, as we start to solve this equation, we have to clear parentheses. So we get 8x squared plus 16x plus 3 equals 5x squared plus 5. Now we're going to transpose this, and on this side get 3x squared. Transpose this becomes a negative 5x. We get plus 11x plus 3 equals 0. Now we have a quadratic equation in standard form. You could think, well, could I factor that? And again, there are no factors of 3's here that would ever give you an 11. So the next thing we go to, we might think of, is completing the square. Well, that would be very challenging. I wouldn't do that, too many fractions. So our general multipurpose is the quadratic formula that you may remember is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. But to use this formula, we must identify our a term, which is 3, our b term, which is a positive 11, and our c term, which is a positive 3. So then you take this and put it into the quadratic formula. So starting off, and let's just do it here, x equals, now a negative b b is 11, so this is a negative 11, plus or minus the square root. Now if you square b, and this will always be positive, this is 121, minus 4, which is in the formula, and I forgot to put the c there, I might have said it, 4ac. 4, and a we said was 3, and I would physically do this on your homework log. and then c is a positive 3. And all of this is going to be over 2 times a, which is 6. Now you grind this out, reduce where you can, and that's what you're going to put here. Because they want, you're going to use radicals, probably. And if this under the radical sign is negative, it would be an imaginary number. And you're going to get 2 sets of answers, because this part for 1 will be plus, this part for 1 will be negative. So, keeping in mind what do we need to do with something like this, we get rid of parentheses. This is x squared minus 9x equals x minus 28. So we're going to put this in standard form by subtracting an x from both sides, x squared minus 10x. Bring this over, a positive 28 equals 0, putting it in standard form. Now again, if this would factor, that would be ideal, but if it doesn't factor, this might be a good possibility for completing the square. I tried, I don't believe it factors. So we're going to use the technique of completing the square. And we start off by taking our c term and moving it to the other side as a negative 28. We then take this part, we said, and put a parenthesis that we want to complete the square. So this x goes there. We take half of our b term as a negative 5. And now we get our new c term up here because let me put this over here. And I will erase this now, so that when we square this, this becomes a positive 25. And to keep this balanced, we needed a positive 25 on this side now. So when we do this, this side now becomes a negative 3. And we have 1 now. We can use the square root property. Take the square root of that side, which becomes x minus 5. And we go plus or minus the square root of this side, which is a negative 3. Keep in mind this is going to be an imaginary number, so we're going to take out the I here. And then we can do it like so. And we'll let you finish that. And we should mention that this process is called completing the square. We've used that technique, completing the square. In example 4, they're asking us to determine the nature of the solutions of the equation. Well, for this, we use a part of the quadratic formula that's called the discriminant. This is the discriminant. Now, remember, this is plus or minus. And we had said, if when you do this function under the radical sign, and it's a positive number like 5 or any positive number, then there are going to be 2 real number solutions. If under this radical sign it ends up being a 0, then because it's plus or minus 0, there's only 1 real solution. And then we had said that if for some reason under the radical sign you end up with a negative value, whatever it happens to be, then these are going to be imaginary solutions. 2 imaginary solutions. Okay, so let's look at what we have here. Well, in this case, notice our b term is missing. If we would like, we could put a value for b that doesn't have any value, but we want to identify our a, b, and c out of this equation. So our a term is going to be 1. Our b term, in a sense, there isn't any because it's just 0. And our c term is this. So when we put this under the radical sign and we square 0, we get 0. But then we get a negative 4 times 1 times 15. So under the radical sign now, you're going to get a negative 60. And what did we say that answer was? And we'll leave that to you. So we have our basic formula here, where S is the feet above the ground. This is our t squared times this as part of the formula. And our initial velocity, they're saying, is 4 miles per second, or 4 meters per second, I guess. And that is where we put the 4 here for initial velocity. So the first thing we have to do is put it in standard form. Minus 300 now. And we need to solve for t. So I would suggest this probably is not going to factor, that you're going to find your a value, your b value, and your c value, substitute it into the quadratic formula, and once you find the value, you're going to look for a positive solution, not the negative value, and then you're going to round it to the nearest tenth. So I've done some substitution here, and a little hint would be we don't need the negative value. So we only have to find its positive value. And as we look at this, you may note that this is a negative times a negative. So this is going to be a positive. So I would work this out, take the square root of it, subtract it from, or subtract 4 from it, and then do this multiplication and then divide this into your answer. Again, you're using a calculator, but you need to put the work in carefully. In this example, we're asked to use this formula for free fall, where this is the distance we're falling, and it figuring out what the t would be. So we substitute 175 for the s, and now we're going to put it in standard form. 16 t squared minus 175, and we want to solve it. Now we could use the quadratic formula, and another method, by the way, since you are using your calculator, let me give you a little hint on that. You could do it this way, just divide both sides by 16, and now you're going to take the square root of this side, and again you don't need the negative value, so you're just going to take the square root of that. So t would equal, put that in your calculator, and you're rounding off to the nearest tenth again. So for this one, in a similar way, basketball player, vertical leap 35 inches. So the vertical leap is 35 equals 48 t squared. So you could put it in the quadratic formula, or the shorter way, transpose the 35 to this side, and then divide both sides by 48, and then take the square root of both sides. We don't need the negative value here. We're only interested in a positive value. And watch, you're going to round to the nearest tenth. So remember, if it's 4 or less, you drop it. 5 or more, you add 1 to get to the nearest tenth. So for example 8, they've given you a little diagram. A ball is thrown upward, goes up for a while, and then it falls to the ground. And we're wondering, how long does it take to reach the ground? So what is the level of the ground? The level of the ground is 0. Okay, so one of the things you can do is multiply everything by a -1, and this becomes positive, this will become negative, and this will become negative. I think that would probably be a good idea. So we get 16t squared minus 48t minus 640. Okay, so you identify your A, which is 16, your B, which is -48, and your C, which is a -640. Now you could actually divide everything by 4 here, too, if you'd like. Or, yeah, I think so. Or you can divide maybe everything by 16. Yes, if we divide this by 16, there's a 1. 16, there's a -3. And 16, there's a -40. And I believe this will actually factor. Always want to keep that in mind. And this is t, and this is t, and this is 8, and this is 5. And one's going to be negative, and one's going to be positive. And we will reject the negative one once we find our answer. So there's a good hint then of how to do this. Okay, this is a rectangular field. So our big rectangle up here is 80 by 150. Now we're going to dig up a border just inside our perimeter here that's going to be of equidistance for a new walk area or something. And what's left now is half of the old area. So what we need to find out first, what is our old area? Well, it would be 80 times 150. 80 times 150 is 1,200. Now what's half of, 12,000. What's half of 12,000? 6,000. So our new area inside is 6,000. We don't know how much of this we've cleared around it, but the dimensions of it is the same. So now we have to figure out what would be a formula to give us this area. Well, it would be this minus these two x's. So over here it's going to be 150 minus 2x. That's the length, in a sense, of this one, these two x's here. And we're going to multiply that by 80. Now minus these two x's. It's the same. And that will equal 6,000. Now, what we have to do is FOIL this, which is what I'm going to do right now. Well, we already know that this is 12,000. Now when we FOIL our outers, we get a negative 300. When we FOIL our inners, we get a negative 160, which will give us a negative 460 x. And then when we FOIL our last, we get a positive 4x squared. And all of that equals now 6,000. So, in order to solve this, we have to put it in standard form. So I'll put the 4x squared there. This goes here. And now I'm going to subtract 6,000 from both sides, and I get 6,000. And that equals 0. Now you could work with these big numbers, putting it into your calculator through the quadratic equation, but we could divide everything by 4 to make our numbers smaller. And I'll write it over here. We get x squared minus 115 x plus 1500 equals 0. Now, I don't know if you see it, but this is going to factor very well. You could still use the quadratic formula, but factoring is nice too, if you see it. Now, this is going to be 15 times 100, and they're both going to be negative. Now, I'm going to do this for you because you'll see, and you'll probably get one with slightly different numbers here. X is going to equal 15, or X would equal 100. And you might say, oh, we got two answers, and they're both positive. Now, the only thing is, if X equals 100, would it fit with the overall width of being 80? No, that's not going to fit. So we have to reject this answer, and then 15 happens to be our answer here. Because if you put 100 there, that's not going to work. Okay? And by the way, what were the dimensions if we wanted to figure that out? This is going to be 30. So 30 from 80, this is now 50. And 30 from this is now 120 here. And if you go 50 by 120, that's 6,000. And there's, I worked that one out completely for you, but I guess 1 is okay. Well, this is sort of a funny example here, but here's our building. Now we're going to have a ladder that's 13 feet long, that's standing on level ground, and it's 12 feet from the base of the building. So this one is 12, and we're wondering how far up does it go. So we often think of the short side of a right triangle as A, this is B, and this hypotenuse here is C. And we're going to use the Pythagorean Theorem, A squared plus B squared equals C squared. So we know a few things. We're going to square 13, and we're going to get 169. 13 squared is 169. 12 squared is 144. We're going to subtract 144 from both sides, and we get 25. And we're going to take the square root of both sides. So what is the height that the ladder reaches here? What is, oh, I guess I did that wrong there a little bit. Well, I'll just change my sides here. So we're looking for b then rather than the other way around, because that's where I plugged the numbers in. So what is the height of b? Well, we took the square root of this side, square root of that side, and we don't, again, use the negative value because distance is positive. All right, well, let's see how you did, or I did. And I got them all right, so another 100 on my list here. And good luck to you on yours.